Algebra 2, lesson 119, absolute value inequality. So these are going to be using the new notation that we learned in lesson 117. Yeah, 117. It's going to be in set bubble notation. So if you remember, we'll go to this first one. This is actually the second example. But we've got graph x is a member of the set of j, which if you remember is integers, such that the absolute value of x plus 2 is less than or equal to 3. This absolute value means that we have to test the positive and negatives of the graph. What that tells me is that this is going to be a conjunction or a disjunction. The first thing that you can do, as soon as you see this absolute value, is realize that you have to deal with the positive and negative. So what I'm going to do is I'm going to go over here, and I'm going to copy, I'll go ahead and copy the problem. I've got x is a member of a set of integers such that x plus 2 is less than or equal to 3, end of set, right? Okay, right, yeah, so the first thing I'm going to do, I'm going to focus on this section of the equation, and I'm going to try to kind of write it in a way that's a little more familiar to you guys that we've been using throughout most of the school year, which is in our conjunction-disjunction format. So as soon as you see there's an absolute value, what you're going to have to do is you're going to have to mimic this inequality on both sides of the absolute value of x. Oops. Wow, that was a bad. Let's try again. Red's not the right color for this. Let's go with blue. Blue is obviously the right color. So let's rewrite this as a conjunction or a disjunction. So I'll have the absolute value of x plus 2. That's going to be in the middle. Now this symbol I'm going to copy on the left and right sides. On the right, I'm still going to have positive 3. However, on the left, now I'm going to have negative 3. Right? So I put the opposite integer version. So if this was a negative, then I would have the positive, right? So I'm going to do both. Now I can see this, I can read this a little bit better, I know what to do here. I'm going to subtract 2 from all sides. That gives me x, this is going to be 3 minus 2, which is 1, negative 3, negative 2, gives me negative 5, right? So now I've got a conjunction. The way I know it's a conjunction is because this is less than, right? So the graph of this is going to be, let's try the graph in a different color. Maybe we'll try red again. Let's give it a shot, red. Okay, so the graph of this, I'm going to have a right point of 1, a left point of negative 5. Okay, these are going to be closed dots on each of those, right? And normally, since it's a less than, I just connect the line, but I've got this domain issue. X is in the subset of integers. So now I have to do every single integer. So that's negative 4, negative 3, negative 2, negative 1, and 0. Right, so this is going to be my answer now. Right, negative 4, negative 3, negative 2, negative 1, 0. Right, that's my answer. And that's how we graph these absolute value inequalities. Now, what if we end up having a disjunction, right? So when the absolute value is greater, then we're going to have a disjunction. So let's see what that looks like. We'll take an example problem. They tell us to graph the absolute value of x minus 2. Why did I switch to parentheses? Let's graph the absolute value of x minus 2, which is greater than 3. And then we'll, oops, I forgot to do the set notation. We'll say x is in the, let's do reals, because I want to make this easy. So x is in the subset of reals such that absolute value of x minus 2 is greater than 3, end of set. Right? Let's graph this. First thing I'm going to do, I'm going to go to my trusty color blue, not red. I'm going to grab this and turn it into a double-sided inequality to show the disjunction. Greater than 3, and then we're going to put negative 3. Great. Next step, I'm going to go ahead and solve for x, adding 2 to everything. Now I get negative 1, x, and 5, right? And then this shows me the disjunction, right? So let's go back to red for graph. I'm going to have 5 as my number on the right, negative 1 will be my number on the left. They're not equal to, so I'm going to use open circles. And since this is a greater than and a greater than, I'm going to draw them going apart. From each other. I just realized you guys can see it. I've been making that mistake all year. Anyways, so this is how we do disjunctions. Just remember, if it's read as less than, conjunction, greater than, disjunction. That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.